Okay, part 2. So let's go back to our example here. For any real number a and b and any integer m. So what you have to do here is you have to distribute your exponent m to each base or variable a, b. So if you have open parentheses a, b, close parentheses to the m, it actually is a to the m, b to the m. So you're just multiplying them next to each other, which is what the original problem says, but we just now have m as our exponent. So let's look at our first example here. If I have 5cd, close parentheses, cubed. What I'm going to do is I'm going to take the 3 exponent and I am going to distribute it to the 5, the c, and the d. So now I have 5 cubed, c cubed, and d cubed. Now, if I look at this, the only thing that I can simplify is the 5 cubed. Now, please remember, 5 cubed is not 15, okay? It is actually 5 times 5 times 5. So that would give us 125. I would leave the c cubed, d cubed, because I cannot do anything with those. I cannot add them, multiply them, nothing. So your final answer would be 125 c cubed, d cubed. All right, so let's look at number 2 here. Negative 2 xy cubed to the 5th. All right, now it's very important that we leave the negative sign for that negative 2 inside the parentheses. So when we rewrite this, we want to leave negative 2 to the 5th, x to the 5th, because we have to distribute that 5. But right here, I have y, 3 times 5. Because this is the power of a power. All right? So now let's simplify that. So we have negative 2. Now when you put it in your calculator, you have to make sure you leave the negative sign inside the parentheses. So it'd be open parentheses, negative 2, close parentheses. Okay, you'd hit this caret sign right here underneath the clear sign to the 5th. You'd hit enter. So we'd get negative 32. So we have negative 32. I can't do anything with x to the 5th. And then I have y. Now 3 times 5 is 15. And I'm done. That is my answer. Now, how do you know when your monomial is simplified to this simplest form? Was when each variable base appears exactly once. So I only have one x and I only have a y down here. I don't have another x to the 3rd, okay? So that means I only have one variable base. There are no powers of powers. A power of power looks like this, where you have a power and then on the outside it's times another power. So there aren't any powers of powers left, and all fractions are in the simplest form. So what I want to do right now is I want to look at 2 of your homework problems to help you get in to see what I'm looking for tonight. Let's look at number 1 here. The first thing that I notice is that I do not have a power to a power. I do not have an exponent times another exponent. So what I'm going to do is the first thing I think of is separate. Separate, separate, separate. Separate coefficients, separate variables. So let's go with number 1. And I have 3x cubed y squared. And then I have 2x squared y. So what I want to do here is I want to separate each one of these. So I'm going to use my highlighter to help. So there's my coefficients. My x term. And then we have a y term. So what I'm going to do is I'm just going to write these together. So I have 3 times 2. Okay. Now I'm going to go to the green, which is x cubed times x squared. And then I have y squared times y. Now, do you see how I have kept the letters together, the bases together. So when we have a situation like this, we actually have product of powers. And product of powers says that I add. So 3 times 2, or I add the exponent, sorry. 3 times 2 is 6. Right here would simplify down to x, 3 plus 2. And here this would simplify down to y, 2 plus, it's a 1. Because just like when you have a variable, there's always an imaginary 1 in front of it. There's always an imaginary 1 coefficient. A 1 exponent. So now we have 6 x to the 5th y cubed. And that would be your answer for number 1. 6 x to the 5th y cubed. Now let's look at number 6. Number 6 looks like it's a difficult problem, but it's really not. What you have to do is you just have to simplify what you have. Okay? So let's write this all out here. So number 6, 2a squared b cubed c to the 8th, 5 b to the 8th c squared, and then negative 36 a to the 7th b squared c to the negative 10th. Now just to help me, what I'm going to do is I'm going to go through, I'm going to highlight. Well, I have coefficients. And then I have an A term. I don't have an A term in that second one, but it's okay. Let's highlight the C's in green. We'll do B's in orange. Now, what you want to do is you want to concentrate on the color. So let's start with yellow. 2 times 5 times negative 36. Now I'm just going to show you a different way that you can work a problem if you prefer to do it this way. This would be negative 360. Okay, so these were my yellows. Now there's always more than one way to work a math problem. Remember that. Okay, as long as you're showing your work, I'll understand. So let's go with the blues. The blues are my A's. So I have a squared times a to the 7th. Now remember, that gives you a to plus 7, which gives you a to the 9th. Okay, so right here, this is this answer. Now this one is this answer. Okay, so now let's look at B's. So B is, I have b cubed times b to the 8th times b squared. Now that gives me b, 3 plus 8 plus 2. Now you don't necessarily have to have that parentheses. That is okay. So I actually have b to the 13th. Okay, now let's look at our c's. C to the 8th times c squared times c to the negative 10, which gives me c, 8 plus 2. I'm actually just going to write negative 10 instead of plus negative 10. So let's use my handy whiteout again here. So we have 8 plus 2 minus 10. Okay, and that's actually going to give me to the 0 power. Well, if you ever have a 0 exponent, this actually cancels out and is 1. Okay, so if you look at it, you have negative 360, a to the 9th, b to the 13th, and then the c to the 0 is actually 1. Well, then you would have to combine your two numbers, which just leaves you with negative 360, a to the 9th, and b to the 13th. And that would be the answer to number 6. Don't forget to show your work and complete your homework tonight. Thank you.